My name is Connie Lee, and I'm going to be the presenter for today's session. Today's session is going to be on fraction splitting and replicating, and you're going to find these lessons in your Week 6 packet, Lesson 1, and Week 7, Lesson 1. The goals for this session are going to be, we are going to compare and order proper fractions. We're going to convert fractions to decimals and percent. And we're also going to know that percent means part of 100. All right, lesson 6.1 actually has two parts to it. In the first part of the lesson, students use fraction strips to make rulers that measure different fractional lengths. And they use these fraction rulers to compare and find equivalent fractions. For this session, we're actually going to focus on the second half of the lesson, where students learn two different methods for modeling fraction equivalence. Okay? So in this lesson, we introduce two different methods for modeling fraction equivalence. The first method is called the splitting method. And you'll see that the fraction bar on this page is shaded to show 1/3. And to show that 1/3 is equivalent to 3/9, we can split both the shaded and the unshaded parts into 3 equal pieces, okay? Which would give us a total of 9 equal pieces. All right. Okay. So this shows that 1/3 is equivalent to 3/9. Okay. And the ratio of, so you'll see that the ratio of parts shaded to the whole stays the same, and the size of the whole stays the same. Okay. All right, let's move on to the next page. The second method is called the replicating method. Okay, here you see 2 of 5 squares shaded, and to show that 2/5 is equivalent to 8/20, we can replicate this pattern until I get a fraction that shows 8 of 20 squares shaded. Okay. All right, someone's doing that for me. Thank you. Okay, so you'll see I first have 2/5 of the squares shaded. Okay, now I have 4/10 of the square shaded. Okay. Now I have 6/15 of the squares shaded. And lastly, it shows here I have 8 of the 20 squares shaded. So again, showing that 2/5 is equivalent to 8/20. Okay. Now in this method, similar to the splitting method, you'll see that the part to whole ratio stays the same. Okay. But in this method, the size of the whole changed. Okay. Both the part and the whole increased proportionally. Okay. Any questions about the splitting method or the replicating method? They're slightly different, you can see. All right. Shelley made a comment here. The main thing about these methods is that when you split, you can keep the size of the whole the same. Okay. And this is how the kids learn equivalent fractions, right? And when you replicate, we keep the part the same, but the whole changes exactly. Okay. All right. So let's move on to the next page. These are a couple of practice problems from SP7. What I'd like to do is just have different people try some of these different methods, and we can discuss them once everyone's done. So go ahead and just pick one. If you can just, if different people can maybe do the splitting method, if someone can do a replicating method, that would be great. All right, thank you for those of you who volunteered. I just wanted to give you an opportunity to maybe practice a couple of these different methods. Let's look at number one, okay? Number one, again, the part to the whole ratio proportionally increased by 2 this time. And I did some recording at the bottom there, and so the original fraction that we started with is 3/4, and we increased it by 2. Okay, so we're going to multiply it by 1 in the form of 2 over 2, which gives us 6/8. Okay, and so when the kids are sharing these out, it might be a good idea for the teacher to record this as they're sharing out their different strategies. And then same thing with number 3. We originally started with 5/6. We increased both the part and the whole by 3. Okay, so we can record it as such here. 5/6 times 1 in the form of 3 over 3 will give us 15/18. Okay. Any questions about the splitting and replicating method? Now, as Shelley pointed out, I think the main idea here is that the ratio is always going to be the same whether you use the splitting or the replicating method. The only difference is that in the splitting method, the whole doesn't change. In the replicating method, the size of the whole is going to change. All right? Okay, let's move on. All right, this is the flower garden problem, and it's on SP8. In this problem, we asked the students to use different methods and sense-making strategies to compare the gardens of 4 students. And they basically have to figure out who has the largest fractional garden, who has the largest fractional part planted. Okay. One thing that I'm not going to do this online, but I did want to point out that one of the strategies that we want to discourage is just having the kids convert the fractions into decimals. That's not the idea here. We want to make sure that they're getting practice using the 2 methods, which is the replicating and the splitting method. Okay. A question that Shelley wants to ask the group is anyone confused or bothered by either of the methods? Okay, so Susan, you like the splitting method. Most of the time, teachers do like the splitting method. Okay. I think with students, they don't mind the replicating method. It makes sense to them. Okay. I'm not sure if anyone else has a comment about that. Yes. Yes. Is it Joe? All right. Right, and I think the replicating method, I think what Joe's saying is that the replicating method ties in really well with the big one. Okay. Shelley, I think that you could just circle 2 at a time and go from 8/10 to 2/5. That would be reducing. Okay. We can definitely do that as well. All right. Any other comments about the 2 different methods, the splitting and the replicating method? All right, let's move. Shelley, did you want to speak?
Can you hear me? I guess you can hear me. Yeah, I just wanted to share with people that the big one, just for fun so that you know, was actually named by a student. Her name was Kimberly. And I was working with her at one time, and we were multiplying by using the multiplication property of 1. And she really liked putting the 1 around the fraction that equals 1, and she called it the big one. And it really stuck with her. So I would encourage you to use that, because if it works for Kimberly, it might work for you.
Okay, thank you for that comment, Shelley. Let's go ahead and move on. We talked about the flower garden problem. Again, we're not going to be doing it together, but I just wanted to point out one of the strategies that we want to discourage, I guess, from students from using. Okay. Moving on, I wanted to quickly revisit the while you were waiting question. This is actually SP9 of week 6, and most of you noticed that the chart shows equivalent fractions. So for example, if you look at rows 1 and 2, I see 1/2 is equal to 2/4, which is equal to 3/6. I can basically take any two rows. The second row and the fifth row shows me 2/5, 4/10, 6/15, and so on. I think we can also use this chart to find lowest common denominators. If I have 2/3 and 3/5 and I want to find the least common denominator, I can just go down that row 3 and row 5, and figure out that 15 is going to be the lowest common denominator. So that's kind of the idea for the multiplication chart. Okay. All right. Perfect. Let's go ahead and move on to lesson 7.1. Okay. So in this lesson, the students are going to convert fractions to decimals and percents using the replicating method that we introduced in week 6.1. Okay. And they're going to use this 100 square grid as well to convert fractions to decimals and percents. Okay. So let's look at number 1. Okay. Number 1, you'll see a figure A. And figure A shows 17 of the 50 squares shaded. Okay. And what we want to do is we want to replicate that pattern 17/50 onto B, pattern B, or this 100 square grid. Okay. So I would shade in 17, oh good, someone's doing it for me, thank you so much, 17/50, and I'm just going to replicate that until my 100 square grid is filled in. So I see that I replicated it once and I replicated it twice. Okay. And if I were to count each of those shaded squares, I know that I'm going to have 34 of the 100 squares shaded. Okay. I also know that percent means per 100. So if I want to find the percent, I know that it's going to be 34% because it's 34 hundredths. Okay. And because I have 34 hundredths, okay, that the denominator there is a power of 10, and I know that I can write that as a decimal form if it's in a power of 10. So again, 34 hundredths in decimal form would be 34 hundredths or 0.34. Okay. And that's basically the idea. We're using the splitting method, the replicating method, which was introduced in 6.1, and we're using this 100 square grid to help students convert a fraction into a percent and then into a decimal. Okay. One thing that I do want to point out also is that the students may shade in different ways. Okay. For example, in number 2, okay, pattern A shows 17/25. So 17 of the 25 squares are shaded. Okay. Some students might actually divide that 100 square grid into quadrants and basically shade 17 in each of those quadrants. Okay. Other students might actually count out 25, 2 rows and another 5, and then shade in 17 until the 100 square grid is filled in. Okay. Either way, they should see that they've replicated 17/25 4 times. Okay. And so they'll notice that 17/25, and again they can just count the boxes, they should recognize that 68 of the 100 squares are shaded in. Okay. So 68 out of 100. And again, I know that I can find the percent easily because it's out of 100, so that's going to be 68%. And then again, I can write it in decimal form because I see that the denominator is in a power of 10. Okay, so that's going to be 68 hundredths, or you can write it as 0.68. Okay, there's a couple questions that you want to ask once the students have completed this set of problems. One is just for them to look at the problem, look at the fractions, and see if they can compare the fractions. Okay, so what do you notice about 17/50 and 17/25? Okay, students should see that they have the same numerators. So for example, if they have the same numerators, and So if they have the same numerators, the larger denominator is going to be the smaller fraction. Okay. And another, and I think the question on the SP page actually asks which of the fractions above are greater than 1/2. Well, I know that in number 2, more than 50 of those squares are shaded, so it has to be greater than 1/2. Whereas in number 1, less than 50 of the squares are shaded, so it has to be less than 1/2. Okay, and so those are just some different comparing strategies that you want your students to use when looking at this set of problems. Okay. Does anybody have a question or any comments? All right, Shelley, did you have a comment?
Yeah, sorry, it takes a minute for my audio to go on. Yeah, I'm really glad you went over that question, the 1/2, because one of the things I think that we want to work on with the kids is developing good number sense about fractions. And 1/2 is an important benchmark fraction, and so asking questions like, how do you know whether it's bigger than 1/2 or less than 1/2 are really important. And this question, this particular problem is good for that because they both have the same numerator.
All right, let's go ahead and move on to the next page. All right, this is from SP3. You'll see another set of problems. Let's see here. Let's go ahead and have some people practice the replicating method using the 100 square grid, and then we'll just talk about it briefly. All right, let's go ahead and talk about these two problems. Again, in number 1, you'll notice that pattern A, which was 7/20, was replicated 5 times. So the parts increased by 5, and the whole increased by 5 as well, giving us a total of 35 of the 100 squares shaded. And then again, finding the percent and decimal is going to be pretty easy after doing that. Now on this page, you'll notice that the set of problems here have the same denominator. So again, asking questions about how do you compare fractions that have the same denominator and different numerators. And hopefully the students will recognize that if you have the same denominator, then the larger the numerator, the larger the fractional part. Okay. All right. I know with our tools here, it's really hard to shade in, but I really appreciate some of you trying to shade in the patterns here. Thank you. All right, let's move on to the next page. Now on this page, look at number 3. Okay, what do you think will happen when students replicate 1/8 on the 100 square grid? You can type it in, or you can raise your hand, and I can have you talk if you'd like. Okay, so Mr. Diaz says that the rows rows of 10, not 8. Okay, so if I were to shade in one of 8, okay, it's basically shading all of these in. Okay, so that gives me 1 of 8 there. And then I can also shade in 1 of 8, 1 of 8. Okay, so they should see that they can replicate the pattern 12 times. Okay, and then what they're left with are 4 extra squares. Okay, so if we want to estimate what 1/8, what percent of this is shaded, we can say that 12% is about 12%. Okay, or if we wanted to get really precise, what could the students do? You mean 1/8 is about 12% correct. So they can estimate and say that 1/8 is about 12%. And with the remaining 4 squares, they can actually divide it in half, as Mr. Dia suggested, and then shading in one of those halves. Okay, which would give us an exact conversion of equivalent of 1/8, which is 12.5% or 0.125. Okay. And so the idea here is that we want the kids to recognize that they can't complete an entire pattern using the 100 square grid. They're going to have some extra, I guess, squares at the end, so they can estimate what 1/8 and 1/16 is equivalent to. Or they can be precise and maybe divide the 4 into halves and then shading in one of those halves. Okay. And then with the 1/16, you'll notice that they're left with 4 extra squares there as well. And they would have to divide those 4 extra squares into actually fourths, okay, to get the exact conversion of 1/16 into percent and decimal. Okay. Any questions or comments? It says, Helen says, do you think students have a trouble from 12.5 to 0.125? I think so. Again, I'm not sure if we want, I mean, for the sake of discussion, I wanted us to kind of look at it and, figure out the exact equivalence for 1/8. But I think with the students, it's okay to just say it's about 12%. It's about, 0.12. Okay. Shelley says, I was wondering the same thing. Anyone have any ideas on how to help students understand that? If you have any ideas, will you please type it in, or you can speak if you have access to the microphone. That would be a good idea too. Exactly, if they do shade in 1 of 8 on a 1,000 grid, and even though it might be a little bit time consuming, they will see that you will end up with 125 of the 1,000 square grids shaded. Okay. Any other questions or comments? All right, then let's go ahead and move on. Actually, I think that is the end of the presentation. So if you don't have any other questions, I want to thank you for joining us online. If you have any other questions or comments, you can just stay online and we'll be on for a while. Let's see here, next week's session is on fractions, comparing and converting. I think it's from week 7 and 8. Okay. And lastly, if you have any feedback for today's session, or if you need verification for attendance, just email me at clee@math.ucla.edu. Thank you very much and have a great afternoon.
Hey, Connie, thank you very much. That was really clear and concise. Appreciate it.